So here is the next question. There are, instead of state and output equation, he gave you the ABCD matrix. He's asking us to find the transfer function h of s. Now A is a 3 by 3 matrix, so here finding A inverse is a little bit lengthy and a tricky process. So basically there are four important steps. So first one is step 1, calculate the minor of an element. How do you find a minor of an element? So finding minor of an element, say for example, if you want to find minor of this E, okay, so eliminate this row and column, we end up with AC we end up with ACGI. So basically AI minus GC is called minor of E, element E. Okay, AI, so these two minus these two, that gives you minor of E. Once you find the minor, then find cofactor of E. Cofactor of E is nothing but multiply this minor, so cofactor of E equal to 1 minus 1 to the power of rows plus columns. So rows plus columns, which is I times j times minor of E. Okay, so if you look at E, which row it is, that's the second row, and which column it is, second column. So minus 1 to the power of 2 times 2, which is 4. So minus 1 to the power of 4 is positive number, so cofactor and minor in this case are same. Another way of doing this is I always take, to find the cofactor, once I find the minors, then this is plus minus plus minus plus minus plus minus plus. That's easy way. So each element, so when it comes to this element, it's going to be plus. When it comes to this element F, that's going to be minus, like that. Once we find the cofactor, again you need to do the transpose of the final X matrix. Okay, then multiply that with the determinant of X. That will give you X inverse. So all we did, step 1 we found the minor, step 2 we found the cofactor, step 3 we transpose the cofactor matrix, step 4 multiplied that with the 1 over determinant of X. So how do you find determinant of X? Determinant of X, finding determinant is easy for a 3 by 3 matrix. So find the determinant, take any 3 elements, rows or column, usually will follow either row or column. Most of the times if there are all the elements are there, we always go with that, and multiply that with the cofactor of each element. That will give you determinant of that matrix. Okay, we'll go with this. So here A is given, so first thing we need to find h of s equal to C times Si minus A whole inverse times B plus D. So here D equal to 0, so I do not worry much about it. So first thing we're going to find Si minus A. So it's a 3 by 3 matrix, so I have 0 S 0 0 0 S 0 0 0 S minus A matrix. I have minus 1 0 0 0 minus 2 0 0 0 minus 3. This will give you so I have only diagonal elements, so it's going to be S plus 1 0 0 0 S plus 2 0 0 0 S plus 3. So here we have Si minus A. Now you need to find Si minus A inverse. So first we need to find determinant of Si minus A. Determinant of Si minus A equal to, so I'm going to take only, any row or column. So if I take this row, okay, so Si minus A, the determinant for that is S plus 1 times S plus 2 S plus 3 minus. So to find the determinant, it's going to be S plus 1 times minor of s plus 1. So minor of s plus 1 is nothing but s plus 2 times s plus 3 minus 0 times 0. Okay, minus 0 times minor of 0, minor of this element, which is going to be 0 anyway. You are multiplying with 0, so you don't need to worry. And the third plus 0 time a minor of 0, minor of this 0, which will, I mean, it doesn't matter, whatever that number is, you're multiplying that with 0, so we'll end up with 0. Okay, so if you have only diagonal elements, the determinant of the matrix is just multiplying all those three diagonal elements. So here the determinant is s plus 1, s plus 1, s plus 2 and s plus 3. That is the determinant of Si minus A. Now we'll find Si minus A inverse equal to, you already did inverse in homework 1, so I'm not going to explain it in detail. So now cofactor of Si minus A and then transpose it. So for that I ended up with s plus 2, s plus 3, 0, 0, 0, s plus 1, s plus 3, 0, 0, 0, s plus 1, s plus 2. Okay, that's Si minus A inverse. Now I'm going to multiply this with C, and then at the end I'm going to multiply with B. So C times Si minus A inverse so basically, I mean, you can clearly see I found this cofactor of Si minus A transpose is nothing but, you have three elements there. To get this element, eliminate that, multiply these two. To get this element, eliminate this element and multiply the remaining two elements. Third one, same thing. To get this element, multiply these remaining two elements. This is valid only if you have only diagonal elements. Okay, that's kind of shortcut. So C times Si minus A inverse, what we have, C equal to, I highly recommend you to do whichever has higher number of zeros. Say for example, if you have B 1 0 0, C as 1 1 1, first do it with B, so you can eliminate, I mean, couple of elements. That will make it our life easier or calculations easier. So here I have C equal to 1 0 0 and Si minus A inverse, I have s plus 2, s plus 3, 0 0, 0, s plus 1, s plus 3, 0, 0 0, s plus 1 and s plus 2. Now you will end up with I mean the determinant here, which is right there. Okay, now if I multiply this, what is the size of this matrix? 1 by 3, this is 3 by 3, so you will end up with 1 by 3 matrix. So C times Si minus A inverse equal to, I will end up with s plus 2, s plus 3. Okay, that's the first term. Second term 0, third term 0. 1 over s plus 1, s plus 2, s plus 3. Now D matrix, C times Si minus A whole inverse times D, you will end up with times B, s plus 2, s plus 3, 0 0, and we have B equal to 1 0 0. Okay, So here, and I have s plus 1, s plus 2, s plus 3. So I'll end up with s plus 2 over s plus 2 times s plus 3 over s plus 1, s plus 2, and s plus 3. This is the transfer function. Now in this transfer function I have 3 poles and 2 zeros, and there is a pole zero cancellation, but do not cancel these poles, because if you cancel them, then the resultant system is going to have only one pole. That one pole system model is going to represent different system than the given system. So here, never ever cancel pole zeros. Thank you. I'll stop this video here, and I'll continue next video, next example.